All right. So, hello everyone. Let me get the agendas for today's stream. Uh, Apologies, there was a mix-up and some technical difficulties with the live event link, the previous one. So I had to create a new one. All right, so today apparently we're talking about Kubernetes cluster architecture, namespace isolation, role-based access control, RBAC, all right, policy design, network flow logs, Calico and fluent-bit integration. All right. Don't know about you, but I'm gonna learn some stuff. All right. So let me figure out where is the chat window. And I'll be with you shortly. Chat window. All right. And I need to get the chat to pop out. Alrighty. And now everything is set. Great. Without further ado, oh, great. So the command line is up. Let's make it a little bit bigger. All right, so in our last session, we talked about containers, we created a cluster, and we figured out how these workloads and cluster components can talk to each other. Well, now that we know how to create a cluster, let's take it up a notch and talk about the stuff inside the cluster. I'm going to quickly create a couple of nodes and hopefully wait for it to finish successfully. In the meanwhile, let me show you what I mean when I talk about the Kubernetes architecture. All right, so Kubernetes components. In Kubernetes, there are nodes that have different roles. The control plane is the brain of the operation. It hosts components such as the cloud control manager or controller manager, the API server, sometimes etcd, but the database or etcd could be also hosted outside. There's also a scheduler, which is in charge of queuing everything and making sure everything runs smoothly. Now, nodes, on the other hand, run a kubelet process, which is a way to send information to the API manager and to the API server and talk with the control plane about the things that they are doing. So all these components that I talked about needs to talk to each other in one way or another. For instance, Kubelet in the node side uses a TCP port in order to communicate with the API server. Now, don't worry about the ports and stuff. We're going to dig into it in a minute, but the whole idea is that everything can talk to each other. So the orchestrator, which is Kubernetes, can deploy your workloads and figure out what needs to be done in order for you to have your awesome workload running. Now, here, I need to swipe to, all right, so I've created a cluster with 2 nodes, and by the way, I'm using multipass to just ease the pain of configuring everything from scratch, but as you can see, I've got 2 VMs. One is the control VM. It's going to host my control plane. The other one is node 1, which is going to be my node. And now I'm going to transfer my Kubernetes key to the folder that I'm working on, and I'm going to export it as my kubeconfig, so I will be able to. Think I missed something in here. No. So now I should be able to, yep, connect to my cluster. All right, we talked about this. Our cluster is not ready. Well, the problem is that we don't have a CNI. If you want to know how I know it, please watch the previous session, which we talk about this in details, and there is also a workshop that you can complete in order to figure out why this is the way it is. Now, right now we're gonna install Tigera operator. If you remember, Tigera operator is the brain of the operation. It will be your friend in order to install Calico. You will instruct what you need, and the Tigera operator takes care of the business, and configures everything and deploys the Calico for you. So now, one thing to note is that we're gonna need the Calico manifest. So in order to get the Tigera operator manifest, you can go to the documentation website. I already installed it. Great. Now, after it is installed, we're gonna do something else as well. All right, so right now, our cluster is using the public image repositories from the internet. Now, how do I know that? Well, the installation manifest for Tigera operator, if you look at it a little bit closely, you can see the image repository is Quai. Now, since we are going to secure this cluster, it would be way better to host everything on our own private repository. So let me just quickly spin up another VM that would play the role of repository for us. It's going to take a minute. But in the meantime, we'll be able to look at the, let me see, what is the, all right. We'll be able to look at the documentation website and where we can find stuff. So it's going to be this one. Yep. All right. So docs.tigera.io. It's all you need. Depending on what version of Calico you're running, open source enterprise, which has a lot of features, and Calico Cloud, which offers more features. Select your variation, then install Calico, Kubernetes, and quick start. You'll be able to get the link for Tigera operator. There is some explanation about the next steps, and by the end, you'll be able to equip your own cluster with the Calico Cat. All right, so let's get back to our cluster. Now, I've got another node, another VM, private repo, which will host our images. All right, so one thing to mention, in order to send our images to the repository, I need to add the image. Oh, I need to add the images, push the images to the repository, which is going to be with, my local Docker. Now, in order to push them, I would also need to make some modifications to my local Docker. You would have to do the same if you are using a private certificate for your Docker, for your private repository. As you can see, Docker tried to push, but due to its configuration, it wasn't able to do this. Now, the fix is almost easy. You just need to go to cd docker daemon. I also need to copy this. All right, so insecure registries. Yeah, I know it is insecure, so. All right, so now if we push the image again, it should work. Yay. All right, so similar to Kubernetes, Calico has a lot of components. Let me find the picture. there is. All right, so let me put this in the chat so everyone can. Oh, hello. I've got a customer who's typing. Great. So here is the architecture about interconnection. There's also a component architecture. Let me share the. All right. So let me just quickly. All right. And this is the component architecture. Now in here, these are the, whoa. So these are the different components that are in play when you install Calico. And depending on which feature did you turn on, these would be running in your cluster. For instance, if you're using BGP, then BERT would talk to either other routers or other nodes. It depends on your configuration, but anyway, these are all the things that you would need in order to figure out what is going on inside your cluster. But again, I'm getting ahead of myself. We'll talk about everything in a minute, and we will write policies that hopefully works. All right, so after pushing the first component, I need to push the other ones. All right, so now that it's trying to push all the components, let's talk about the components. So first one is Taifa. Taifa is similar to a database cache. So it communicates with the API server, and all your Calico nodes will talk to Taifa instead of API server. Now you might be wondering why. Well, the benefit of having Taifa is if you got a lot of nodes, then all those nodes need to acquire information from the API server. Well, that would put a load on your Kubernetes cluster. Instead, Taifa would talk to the API server, and all Calico nodes would securely talk to Taifa in order to get their own the information required. Next one is kube controllers. Well, kube controllers is a Prometheus sort of information export that gives you information about the stuff that are running inside Calico. For instance, how many pods are running, or what is the number of policies that are in effect in your cluster. The other one is CNI. Well, CNI is another component that would install the required CNI configuration. The config file in CNI net.d. So it's etc CNI. Sorry, it's /etc/ I can actually show you. So, all right. So multipass shell node 1. All right. So it's etc net.d. Sorry, etc CNI net.d. Yeah, here. Stuff that would go in here, and the it will also populate OPT Calico somewhere. So let me just find Calico node. Oh, I didn't install it. Yes. All right. So we'll come back to this. I need to install Calico, but these are CNI. Where is it? So CNI is those files, the CNI plugins, and everything that you would need. The other one is node driver register, which would be everything that we would need in order to communicate with the node. CSI is the file system driver in order to offer a way to interact with the file system. If you remember from the previous session, Calico would call on CSI and not the crime scene investigator, but the file system. And it would communicate with your underlying file system. Ooh, and there is Calico node, which is the binary or brain of Calico. It's Felix, brain of Calico, and Bird, and other stuff that are working as your control plane and the data plane part. The other one is pod to daemon, which is Felix volume. This is a deprecated version of file system. CSI is the successor, so we're not worried about that. This is removed in the later versions as it is not supported anymore by Kubernetes. Calico API server, which is something interesting. If you want to know more about it, let me know. But just to give you overview, it's a HTTP server that allows you to interact with the Calico API groups and all the stuff that we store in the data store. So if you're a DevOps, this is if you're a DevOps engineer or you want to automate something, this is the place to look for. There's actually API. There is actually an API that you can consume with REST and write your own automator. All right, let's get out of this one. Now I need to install Calico. Again, nothing fancy. We talked about this in our previous session. It's just an installation manifest. It will configure Calico. Now, hopefully this time, if I come to my node, yes, there will be files, and these files are the configurations that Calico will use in order to communicate with the API server securely. And the other one is what Kubernetes would use in order to figure out what CNI is installed and what are its capabilities. All right. Now that we have found a file and hopefully everything is ready, let's go to the next step. Oh, by the way, if you I do have it. All right. What did I do here? Yes, all right. So that's a case-sensitive problem. But if you look closely, all my Calico components are pulled from my private registry, which is something that I've mentioned to Tigera operator. So it was what I did was just like inside my installation manifest, I asked the Tigera operator to install everything from the private registry. That's all you need to do. Just like bam, everything goes together. All right. So next step would be I talked about Kubernetes cluster architecture, hopefully namespace isolation. If you got any questions, by the way, just shoot it in the chat. Hopefully I know the answer, but with my experience, I usually don't. However, I can get someone brighter to answer you. Actually, some of the people who I work with are the ones who create and maintain Calico. So let me know. All right. Now, namespace isolation. If you remember in our previous session, I talked about namespaces. So pretty much all you need to do is just create. Pretty much what you need to do is find a correct link to your manifest and create your namespace. That's all it is. Now, when I talk namespace isolation, it is not on a networking level. It is on an application sort of layer. So your applications will be confined to this namespace if you add them. If you add the namespace in your workload manifests. Now, in terms of RBAC, RBAC is the way that Kubernetes is the default way that most Kubernetes clusters try to permit or deny or see how permissions are done and try to apply them to your cluster resources. So for instance, if I want to deploy a monitoring solution, I would create a cluster role, which would be a role that would affect my cluster as a whole. So I don't need to go to each node in order to create a permission. I just create a cluster role and it would be affecting my cluster and all my nodes. All right. Now, while most of the stuff in computer is automagic, unfortunately, or hopefully for the best, things that have something to do with permission are not automagically. You need to be very careful what you do, and you need to specify what are the things that you want to access and how you want to access them. For instance, here, my cluster role wants to access all the API groups, but the only thing that it needs to communicate with is /metrics, which is the default way for applications that are using Prometheus to export their information. Now, because API groups of like all sorts is a little bit loose, we tie this cluster role to certain resources. So all API groups, however, only endpoints, services, and pods. Now, next step would be creating service account. All right, so service account is the username that you can associate with your workloads in order to pinpoint what workload is using what role. Now that we have the role and the username, we need sort of a glue. Now the glue here is a cluster role binding. All right, so the cluster role binding is telling Kubernetes for the cluster role that we created, which was Calico Prometheus user, stuff that can use it are service accounts with this name and in this namespace. After you create this, you actually interacted with the RBAC, you created a user, a role, and glued these together, and now you can use this name or service account for your workloads. If you are wondering how we can see it, there is a documentation that I wrote many moons ago, which goes into detail of the sort of things. Let me share the link with you. Gara log shift left. Got it. All right, so here is the link, and here is the blog. So basically, I go through the steps that you need to. I go through all the steps that you need to pass in order to get this infrastructure in place. You will have a security team which has access to write or modify all your Kubernetes and Calico policies, and you would have three themes that can interact only within their own namespaces. So with this setup, you can actually have separation of power, and each team can start writing their own network policies depending on their application or workloads that they are developing or operating or maintaining. And you would be the one that sets the actual theme of the cluster, like what are the things that are permitted or not. So if somebody goes off and tries to, I don't know, create a workload that talks more than it's supposed to, your overall cluster roles would deny it. Anyway, all the commands and everything is in there. But again, I'm getting ahead of myself. So let's come back to our own journey. All right, so I got these two. Now, okay, I've been rushing because this part, which is policy design, is going to take a lot of time, I'm assuming. Now, how can I describe policy design? All right, so policy design, whenever you are using Kubernetes, there are multiple resources inside your cluster and outside your cluster. Now, you need to figure out what resource needs to talk to what resource, what other resources, and you need to basically tune your policies in order to only permit the things that needs to be permitted and deny everything else. So this is a path to zero trust. Just to clarify, writing the perfect policies will not be achieving zero trust. Zero trust has multiple steps. For instance, you need to, two-factor authentication, biometric authentication, all sorts of things that can secure your environment. However, this would be one of the steps in order to achieve zero trust. Now, sorry. I need to turn off my phone. All right, so where was I? Policy. Now, when you are trying to write policies with any CNI, you would have, I'm assuming, multiple options. One of the options is Kubernetes network policies. Now, Kubernetes network policies are a great tool to secure stuff, but they have some limitations. And in order to figure out Kubernetes network policy limitations, the best place is the Kubernetes documentation. Here is the link. All right. So let's say we want to do something that is not possible with Kubernetes network policies. Well, plug in a CNI like Calico would allow you to write more complicated policies. So how would you tell Kubernetes what sort of policy you are trying to write? Well, this is actually happening this can actually be conveyed to Kubernetes by the header of your manifest that you are trying to execute. For instance, Kubernetes policy uses networking kates.io v1 API version, and the kind is network policy. Now, Calico offers a network policy resource and a global network policy resource. The network policy resource works in namespaces, and a global network policy works for your cluster as a whole. Now, the network policy that Calico offers has better utilities that allows you to pinpoint what traffic needs to be either permitted or blocked. Now, each policy that you write will have a rule or multiple rules. These rules will affect either your ingress traffic, which is incoming, or outgoing, which is egress. So when I talk about incoming and outgoing, it depends on your perspective. For instance, if you're working with a workload, then your ingress and egress are the perspective of that workload. If you're talking about the host, then your ingress and egress are with the perspective of that host. Now, we'll get into that in a minute, but this is basically what you need to know. Now, when you're using Calico policies, one of the things that is an addition, which is not present, which is not possible with Kubernetes policies, is the order number. Now, the order number is a way for you to tell your policy engine, Calico, what policy needs to be looked at with priority. For instance, if you want to deny everything, you can create a policy with the order of 10. Then all other policies that happens after it would no longer work because you have a specific match and everything would be denied. Anyway, I'm getting ahead of myself. Now, let's get to the point that we're actually trying to write something. Now, in my environment, as you know, because it is since my environment is a test environment, I'm gonna first of all create a failsafe. Now, my failsafe would be a global network policy that would, to affect the whole cluster. Now, explicitly, I'm creating a final allow everything, and I want it to be at the bottom of my policy evaluation, and I need it to allow everything. This would prevent a lockdown if I write a policy that is not correct. Now, the next step would be securing my namespace resources. Again, when you're thinking about a cluster, there are resources that are namespaced. These are your workloads and endpoints, services. These are in namespaces. Even if you create a workload without a namespace, it would go to the default namespace. So in order to do that, all I need to do is to create global network policy that uses namespace selector, a Calico, and this is a Calico attribute, which is which says everything that has a name should be included. So every traffic flow that happens inside the cluster, if it is coming from a namespace, then I want to do something to it. Now, if you remember, I talked about the rules. Now, what are my rules? I've got two sort of rules for this policy. One is for the incoming, the other one is for the outgoing. Now, the incoming one, I have no details for it. So that means I don't care what is happening. If something is coming in, I want to deny it. This is an implicit deny. So I'm just saying everything that matches this criteria, which is namespace, and it is an incoming, just deny it. The other one is egress. Now, in terms of outgoing, Well, my workloads require to talk to my DNS server. I've got like workloads that need to communicate with the DNS server or some other sort of services to just, run. So here for my egress, I'm actually adding a row, and I'm saying, you know what? I want to deny all the egress traffic. However, make an exception. Now, explicitly allow everything that is happening on a UDP protocol on port 53, and it's going to Kate's app kubedns. Now, what is this selector? Well, this selector is not a namespace selector. This is a label selector. If I come to my pods and describe the core DNS pod, hopefully, yes, you should see Kate's app equals kubedns label. And it is actually here. So labels here. So I'm using this label and the global network policy to tell my policy that I want to deny everything. However, there is communication that I need to permit. Now, all those things that I talked about, if we want to put it in a picture, it would be something like this. So inside my cluster, if a pod wants to talk to the core DNS pods, which are in charge of DNS, allow them. As you can see, there is no X on this flow. So it could be namespace A, namespace B. It could be on another node. We don't care as long as it's happening and it's going to the DNS pods, allow them. So how did I do it? I did it with this explicit allow. Now, every other thing that is going to happen in a namespace or for a namespace resource, deny it. So what that means, if my pod wants to talk to another pod on a namespace, deny it. As you can see, there is only one permit here. If my pod wants to talk to internet, deny it. If the internet is trying to get to my pod, deny it. So with one policy, we basically secured almost everything. Now, why did I say almost everything? Well, let me get my terminal. All right. So there are a couple of things that are not in a namespace. Well, what are those things? Well, your network cards are not a namespace resource by default. The host processes, if I come to one of the nodes and do a PS, so everything that is running here most of the things that are running here are not seen as namespace. These are processes that are running on host. Everything that you create in your Kubernetes cluster and add a host network tag to it, that will be something that would run on the host. So for instance, port 6 444. This is Kube API server, if I'm correct. Port 9099. I'm assuming this is some sort of metric for Calico. We'll get to that in a minute. But again, all these things are on my local host, not inside my cluster. And these are using ports, and these are talking to other stuff, either inside my cluster or somebody outside my cluster. And I have no clue how to secure them at the moment with a namespace policy. So now what I need to do is figure out a way to add these resources to my namespaces, or find a glue for addressing these. So for this part, you need to turn on host endpoint policies. Host endpoint policies are a way to glue your policies to non-namespace resources. All right, so let's get started. I'm gonna write another policy. Now, in this one, I'm gonna tweak some of the stuff. So again, this is a global network policy. Apparently, I wanted to affect everything in my cluster, so all the nodes. But the selector this time is Kubernetes IO-OS. Now, this might be familiar to you. Where have you seen it? Let's do kubectl get nodes -o -- show labels. All right. So here there is beta Kubernetes and Kubernetes.io and Kubernetes.io-OS. So this one found it. It took some tries, but found it. So I'm saying to my policy engine, Calico, if you see a traffic and it has this label on, doesn't matter what is the second part, I'm just interested in the first part, that is a traffic that I want to do something to it. Now, what I want to do is I want to specifically allow both incoming and outgoing for that traffic to my local host IP addresses. What are local host IP addresses? Well, local host IP addresses are sockets, TCP sockets that application developers implement or use in order to create cross-functionality between components. For instance, here is a local socket. Here is another local socket. Now, this local socket, sorry, I need a bigger screen. All right, so this local socket is created by the K3 server, which is my Kubernetes distro binary. Now, this localhost socket is created with for a Calico node. Now, you might be asking, Calico node, isn't Calico node inside a namespace? Well, yes, but I talked about host network, right? So hopefully I was right, and there is a host network somewhere here. that we can find. Sorry, network. Nope, host. It's using host. Where are you? Environment. Nope. Not containers. Not install. Not a field. No, it would be in containers. Calico node. So here it's using host. Networking somewhere. Oh boy. Oh shoot. It's a little bit difficult to find it on a live stream, but I'll add it to the Calico live session. Anyway, all right. So going back to our policy. Now, the policy. So with this particular policy, what I did was I said inside my cluster, if there's a node, then whatever pod that wants to talk to the host should be allowed to both send and receive incoming and outgoing to the host OS. Uh-oh, we're 2 minutes out. But anyway, let's get to this one, and we park the conversation and start it in the next session. So anyway, so what is the next policy that I want to do? It's network policy, not a global one. All right, so till now, we only used global network policies, which is the whole cluster. Now, from time to time, you need to be more specific. And for a policy, what is actually important is for you to be as specific as you can be. Now, here, I'm creating a network policy, which is a namespace one. I want it to affect Calico API server. If you remember, I'm sure the DevOps engineers in the stream wrote it down. This is the gateway for everything automation with Calico. Now, I want my Calico API server pods, which are using this label, be allowed to send a TCP TCP communication to my host. Now, something interesting is happening here. I want a namespaced traffic to talk to a non-namespaced resource. Now, how can I do that? Well, similar to the global network policy, I write a selector, which is in all of these traffics, if the destination is to this resource, which we examined, this is my node, a node with a label that has kubernetes.io/os. and if the port is 6443. So this is for Calico API server to talk to my Kubernetes API server. Now, there is a secret sauce that you need to add for this particular policies, which are a namespace resource to a non-namespace resource. And that is namespace selector global. This basically tells the policy engine that you need to figure out a way for these two things from different words to talk to each other. I don't care how you do it, just do it. And with that, we're gonna come back to the pictures that I drew. Hopefully makes sense. So here is the visual representation of the policy. So inside a cluster, my nodes have a namespace, Calico system. So if a pod that has this label in Calico system namespace tries to send out, we're talking with the perspective of that pod. So egress tries to send out a packet or a stream or a flow to Kube API server on port 6443. Please let it happen. All right, so I'm gonna park this conversation here. Hopefully you guys can come back and come back to this recording and follow stuff. I'm also going to populate our project Calico GitHub page. So it's frozen process Calico 5. So let me just put this in the chat. So these are all the information for the last session. This session, after I'm done, I'm gonna add a recap with all the commands and stuff and explanations that I gave. And hopefully for the next session, we will get back to complete our policy design and network flow logs and fluent-bit integration. Well, that was it for today. Thank you for joining in. I'll see you in the next stream.